So here we're going to look at how to draw some Lewis dot diagrams for a few molecules that do obey the octet rule. So for HCN, our first one, our first step is to calculate the number of valence electrons. Hydrogen has 1, carbon has 4, and nitrogen has 5. So if we add those up, we have a total of 10 valence electrons. The next step is to draw a skeleton and connect the atoms with single bonds. So usually if the formula has more than 2 elements, it's going to be written in the order that they would actually be bonded together. If there's only 2 elements, the one that is the least electronegative usually goes in the center. So here we have HCN, so it's going to be H followed by C followed by N. And then we connect everything with a single bond. And each single bond that we draw is worth 2 electrons. So we just used up 4 of our 10 electrons, which means we have 6 electrons left to work with. All right, the next part says where needed, distribute electrons to the terminal atoms. So terminal atoms will be hydrogen and nitrogen. Hydrogen only wants 2 electrons, and it has it. The nitrogen wants a total of 8. It only has 2 right now, so it needs 6 more. So we're told to put those 6 electrons on the terminal atom. Next it says, where needed, place remaining electrons on the central atom. Well, we just used up the rest of our 6 electrons, so we have no more electrons to put on our center atom. And then the last thing we want to do is rearrange the electrons to form multiple bonds so that everything ends up with 8, or when we get to exceptions, as close to that as we can do it. So here the carbon only has 4 electrons and it wants 8. So that means 2 of these electrons that were on nitrogen are going to need to come in and become another bond here. So that lone pair no longer exists, it's part of a double bond. And now carbon only has 6, so another lone pair of nitrogen, we're going to move in and make that into a triple bond, and that lone pair goes away. So when we're done, we have H bonded to C, triple bonded to nitrogen, and we have 1 lone pair on nitrogen. When you're done, you want to double check and make sure you use the correct number of electrons, 2, 4, 6, 8, 10, and that everything has the correct number that it wants to. The hydrogen has 2, the carbon has 8, and the nitrogen also has 8. The next one that we're going to look at is H3CCH3. So again, we need to figure out how many valence electrons we have. Each hydrogen has 1, which that means those 3 hydrogens have 3, these 3 hydrogens have 3, and each carbon has 4. If we add that together, we get a total of 14 electrons to work with. Now we're going to draw the skeletal structure. What we need to remember is that hydrogen can only form 1 bond. So that means hydrogens have to be on the end of a molecule. So HC, those 2 hydrogens can't be connected to the hydrogen, so they have to be connected to the carbon. All right, so H3CCH3. Everything's connected with single bonds, and I've used up 2, 4, 6, 8, 10, 12, 14. I've used up all of my electrons. So at this point, I better be okay because I only have single bonds. So the carbons each have 8 electrons, the hydrogens all have 2, and this one is all set. Next, we have HCCH. So again, hydrogen has 1, carbon has 4, carbon has 4, hydrogen has 1. Again, these are just the valence electrons. This adds up to 10. Skeletal structure would be H, C, C, H, single bonded, which uses up 2, 4, 6, which means I am down to just 4 electrons. Now it says to put the remaining electrons on terminal atoms as needed. The hydrogen does not need any, so we're going to move to the center atoms, and I have 4 electrons, so I'm going to put 2 of them on this carbon, 2 of them on that carbon. Now we need to rearrange to form multiple bonds so that everything's happy. Well, this carbon right now only has 2, 4, 6. This carbon has 2, 4, 6. It wants 8. So this lone pair is going to come in and form a double bond, no longer a lone pair. So this carbon now has 2, 4, 6, 8, but this carbon still only has 6. So then this lone pair is going to get moved in to form a triple bond and is no longer a lone pair. And we have 2, 4, 6, 8 on that carbon and 2, 4, 6, 8 on that carbon. The hydrogens are happy, and again we've used a total of 10 electrons. All right. Lastly, we have NH3. N has 5 valence electrons. Each hydrogen has 1. There are 3 of them, so that's a total of 3. And if I add that together, I have 8 electrons to work with. Skeleton structure, N is going to be in the middle, hydrogen along the outside, and connect each to the center atom with a single bond. That used up a total of 6 electrons, so I have 2 left to work with. I take those electrons and I put them on the outer atoms first, if needed, but the hydrogens only want 2 electrons, and they're happy. So then I'm going to take those electrons and I'm going to put them on the center atom. And at this point, I've used up all my electrons. The nitrogen has the 8 electrons that it wants. The hydrogen has 2. So I don't need to do any rearranging here. I can also know that I shouldn't have to do any rearranging, and I can't, because the hydrogens, everything is a hydrogen bond, and hydrogen can only have a single bond, so I can't create any double or triple bonds in this one.